Sunlight is a mixture of colours. Around 1665, Isaac Newton passed sunlight through a prism and showed that the light consists of red, orange, yellow, green, blue, indigo and violet. Every colour is associated with a small range of frequencies and wavelengths. For example, the frequency of red light is about 4.3 times 10 to the 14 Hertz. That means 4.3 times 10 to the 14, or 430 trillion, red waves pass a fixed point in 1 second. In terms of wavelength, the wavelength of red light is about 700 nanometers. That means the distance from one crest to another, or from one trough to another, of waves of red light is about 700 billionths of a meter. When a light wave encounters a particle that's smaller than its wavelength, the light is scattered. This phenomenon is called Rayleigh scattering. The amount of scattering is inversely proportional to the fourth power of the wavelength. So colours that have higher frequencies are scattered more. When we look at the spectrum of light from red to violet, blue and violet have the highest frequency, so blue and violet are the colours most affected by Rayleigh scattering. When sunlight reaches our atmosphere, the various wavelengths of light meet small particles in the atmosphere and are scattered. Light at the blue and violet end of the visible spectrum, because of its high frequency, is scattered in all directions. The scattered blue light reaches our eyes from all parts of the sky, which is why the sky looks blue. But wait, purple has a higher frequency than blue. It should be scattered more. Why then don't we see the sky's colour as purple? We can measure what proportion of light from the sun makes up each of the colours in sunlight, and when we do this we find that the lowest percentage is represented by purple. There's also another factor. In the retinas at the back of our eyes are cells that are sensitive to red, green and blue, but not to purple. This means that in order to see purple, it must be intense. So the dominant colour we see coming from all parts of the sky isn't purple, but blue. Normally the sun looks yellow, but if we look in the sun's direction at sunset or sunrise, the dominant colours we see are red and orange. This is because when the sun is low down in the sky, its light has to travel through a greater distance of atmosphere, and so even more of its blue light is scattered, and the mixture of colours left shifts even more toward the red end of the spectrum. If we go above the atmosphere into space, there are no particles of gas to scatter sunlight, so all of the light from the sun, which includes all the colours of the rainbow, would reach our eyes, and the sun would appear as its true colour, white.